Good afternoon, folks. Welcome to the next in the series of the RSK Biocenter's first Thursday Club presentations. New for me to be hosting. I've presented a couple of times myself, but it's nice to be in the host seat and not have to present for a change. Mark Tomlinson is going to be doing our talk today. We'll get on to that in a minute. I just want to run through a few housekeeping things if we can first. So first, microphones are auto muted, so you won't be able to interrupt Mark whilst he talks, and that's so that we can get through it nicely on time. And the next one is that there is a question section, chat question section. So if you do have any questions, rather than sort of interrupting as we go along or having a chat thing at the end, if you post your questions in there, I'll try and review those as Mark goes through his presentation so that we can line a few up for him when he's finished. In the event that we do get more questions than we have time to answer, Mark will try and respond to those after the event. So, you know, please do post, even if you think that there might be a lot of questions going in there, just post anyway, and we will try and get back to you. There will also be a survey form sent out about 1 hour after the talk has finished. We do ask for your feedback on that survey form, so please do so. It is important to us to know how we can improve the service. If you've got suggestions for future topics, all those sorts of things, that's the place to do it. So please do take the few minutes it takes just to respond to that. We really do appreciate that for it. And lastly, the presentation will be recorded and a link will be sent out to all the people that registered for this presentation today. So next slide, if you could please, Mark. On to our speaker then. So Mark is a principal aquatic consultant at RSK Biocenter's. He sits in my aquatic ecology team. He's been an ecological consultant for more than 25 years. Before joining RSK Biocenter's, he worked at Econ, a small ecological consultancy based over in Norwich, where he undertook fisheries, lake management and biomanipulation projects in the Norfolk Broads, the Mears and Mosses and estate lakes. And following a spell at the Broads Authority, he returned to the consultancy to run and develop Adler and Allen's aquatic ecology and pollution incident response teams. He's now supporting us in the delivery of a diverse range of projects, some of which include fisheries ecology again. He's been involved in prominent biomanipulation projects in England, including those at the Trinity Broads, Cockshoot Broad and Barton Broad for the Broads Authority and Norfolk Wildlife Trust, and Betley Mere for Natural England. And through these projects, he's co-authored several academic papers on lake restoration and the impact of fish on lake condition, and he co-authored the Environment Agency's R&D technical summary, the use of biomanipulation and advisory booklets. So it's safe to say he knows a little bit about this topic and is probably better placed than most of us are to come and talk about it. Moving on to his talk then, I'll hand over to Mark in a second. So he's going to talk today about biomanipulation, a lake restoration tool. It can be a little bit controversial, it's not top of the list, but it is an effective management tool in the right circumstances. And I'm sure Mark's going to go into that today. And in addition to looking forward to Mark's presentation, I'm also looking forward to some input from the audience and seeing what questions or comments you have on this topic. So without further ado, I'll hand over to Mark and leave you in his capable hands.
Okay, thank you, Pete. Okay, so as Peter just said, that today's first Thursday Club presentation is on the restoration tool biomanipulation. This talk will follow a kind of standard format, a brief introduction, and then followed by the why, what, and how, and then finally I will provide a case study at the end. So, what is biomanipulation? Well, the phrase was first coined by an ecologist called Shapiro back in 1975 when him and his colleagues were working on lake restoration in the United States of America. I've put up a few examples of its definitions up there on the screen from various journals and textbooks. And because I've come from that academic background, there are kind of various phases like biological engineering, trophic cascades, and problematic algal types, but essentially, biomanipulation, it's changing the fish community of a lake to create clear water conditions, and then with that, hopefully, that will then promote plant growth. So why do we need this lake restoration tool? Well, quite sadly, it's because the condition of sort of our shallow freshwater lakes have deteriorated over time, and this will also include designated lakes such as SSSIs and SACs, and also the lakes that are in our key wetlands. So that's the Norfolk Broads, meres and mosses in the Midlands, and also in some lakes in the Lake District. Some of these issues are a result of human-related activities, and probably the main one of these is the process of eutrophication. Eutrophication is a process when lakes receiving increased nutrients, then this will increase their algal concentrations, which in turn decreases water clarity and then ultimately impacts the water plants in the lakes. Now, historically, these increases in nutrients kind of come from agriculture and then runoff, and in online lake systems is through sewage treatment works. Now, with improved technologies and agricultural practices, some of these inputs have been lowered into the lake systems, but unfortunately, the eutrophication process has often caused a shift in the fish community itself. So, when in a macrophyte-dominated lake, often the fish community is very diverse, with species such as rudd, tench, perch, and pike. And often with the eutrophication process, this flips into a fish community dominated often by just one or two species. And this is often roach, and potentially bream, and quite often the population dynamics shift as well, so that it's often dominated by juvenile fish. And for this reason, that often means that there's a large increase in the abundance of the overall fish populations. So another clear man-made issue is that simply of overstocking of fish. So this is particularly an issue in lakes that have commercial fisheries, and usually it is the stocking of species such as common bream, but more often than not common carp, and this often has become an issue in fisheries such as in the meres in the Midlands. So first steps. So if lakes have been identified of undergoing the eutrophic process, or indeed have been identified as having an overstocked fishery, then obviously the first step in the whole biomanipulation process to understand the fish community. So the easiest way of doing that is undertaking a comprehensive fish survey. Quite often this will involve seine netting in the open water. So whether that's from bankside or whether we can do it using pontoons to kind of get in the larger lakes, and also electrofishing of the littoral margins. One of the images there is of my former colleagues doing a point abundance survey of the lake margin. So these techniques, standard techniques, and they are used as the common standards monitoring techniques for SSSI lakes, etc. And so from this, we hope to kind of get a good understanding of the composition of the fish community, but also an understanding of the abundance and biomass of the fish stock, which is really important because obviously it will kind of give you an idea of what the next steps are going to be and what you're up against. And from this, you will then get an understanding of the key drivers. So you've got down the top-down processes and also the bottom-up processes, which can influence how the lake's affected. And I'll touch on that on the next slide. So the other key thing through these surveys as well, and through engaging with the local community and anglers and general people, the stakeholders, is to find out more about the key habitats of lakes. So that can include the kind of understanding where the spawning locations are. Often in lake systems, it's in discrete reed bed areas, part of the margin, but also, where the overwintering sites can be. So this can be, potentially in small sheltered bays, or if it is an online lake, then it could be in the in or outflows. So back to these mechanisms then. So essentially, the top-down effect is driven by the zooplanktophore species such as roach. So essentially, these fish kind of feed on zooplankton, which are the water fleas such as Daphnia, which then in turn feed on algae. So if these are suppressed and predated upon, then that means that there's nothing predating on the algae. So that then can often increase algal concentration, lack of water clarity, which then ultimately impacts us on the macrophytes. The second mechanism is a bottom-up effect. So this is through the benthivores, such as the adult bream and also the carp. So essentially, this is based on their feeding techniques. So because they're bottom feeders, so they search the lake bed for like chironomids and other such food types, and so this, quite simply, it mobilizes the fine sediments in the lake bed, so it increases turbidity through that means. Also through the release of sediments, it's also releasing nutrients into the water column. So again, this can then increase the nutrients, increase the algal, and then decrease water clarity. And finally, is a very direct way, is that if there are still some remaining water plants in the system, then obviously they can directly uproot these through their feeding activities. So following the fish survey and your understanding of the fish community and how it functions, and then what you're up against, and the next step is then to look at the next stage. I said, will you go for full lake biomanipulation, or will it be, can you use an exclosure zone? So to kind of use the full lake examples, so many of the Norfolk Broads were isolated prior to some years ago, with some of the Broads having their sediment removed, and so they were isolated to try and control the nutrient concentrations through the eutrophication process. So some of them were already isolated. They're often privately owned. There's no public access, so there's not an issue in terms of the fishery, etc. So these were kind of often ideal candidates for full-scale biomanipulation. So a couple of these, to give you a couple of examples, is one was Ecological Broad and Pound End Broad. These are already in play and ready for for biomanipulation. So using the Ecological Broad example, essentially most of the roach and bream the majority of the roach and bream were removed using electrophission, by laning the sections of the Broad and removing the fish and returning them to the River Bure. Very successful project. Clearwater was achieved quite quickly, but the plants were slow to return initially. But that said, within 10 years, it was dominated by a quite rare water plant, hollow-lead naiad. So that was a very positive output from that. But not all lakes can have the full biomanipulation. Sometimes it's because of navigation considerations. So in the Broads again, so an image there of Barton Broad, which is actually within the River Ant system. So there's no way that you could do a whole lake biomanipulation on it. So there it was used exclosure system. So various parts were created using barriers. These barriers are kind of like a vinyl curtain, but they are still water permeable. They're chained along the bottom, so they're weighted down, and with floats on top, so they can move with water movements, and kind of attach deep into the bank. So there can be no fish movement. In that image there, you can see how successful they were. You can see that this nice clear blue clear water in those exclosures compared to the main channel with all the boats in. So one of those ones, quite, very quickly filled with plants, and at one point there was it was dominated by a ranunculus species with the white flowers. So even in the summer when it was fully flowered, from a distance it looked like there was snow on the surface. An advantage of these of using the exclosures is often that the fish aren't removed from the system, so they stay within the system, so they're still available for anglers to fish. And this was particularly the case. We found another project that I worked on was at Betley Mere. So Betley Mere in the Midlands, it did have an active fishing club. And what was the process that was used? So an exclosure was created, which kind of enclosed probably about a third of the lake. So the fish were removed, which is predominantly carp, but they stay within the same lake, so it was still available for the anglers to catch. So the angling club was kind of weren't losing any fish, and so were happy with the process. So moving on to the techniques for these fish removals and to ultimately shift the fish community. Essentially, the standard fisheries techniques, so kind of netting and electrofishing. So in terms of seine netting, this is an important one, particularly if the target species are carp, because obviously these are often out in open water. So we will use seine netting techniques. As the image there of a seine net being on the right hand side going out. So these are very good for clearing the open water, but this is also where it's important to kind of have an understanding of where the fish and the habitats are available. Also, fight nets are very good, and obviously they have to be fitted with auto guards, but that still means that you can still catch sizable fish, and also in good numbers. And it's a passive technique, so in terms of fish welfare, really good. So and that's an image of the fight net in the central photograph. But going back to saying how it's important to understand all the habitats, that's where it can be really helpful if you know where the overwintering sites are. So clearly, if you are electrofishing and you know in the winter that fish aggregate in a certain area, then these areas can be targeted, so it's more efficient. And the advantage, obviously, is if this is done during winter aggregations, and with a lower water temperature, there's more dissolved oxygen, and so forth. Again, in terms of fish welfare, that's a very positive way forward. And then in terms of excluding fish, so the times when we are using exclosures, then often we can use a technique using scare lines. So often this is just a long line. It will have weighted streamers coming down off it. So what you can do, this was used successfully in Betley Mere. So what we did was we would pull this line through the water, agitating it, and then so as it moves as a kind of as a curtain through the water, hopefully it's driving the fish away from the area that is going to be excluded. So once we get to the end of that, we then quickly put in stop nets. So hopefully we've driven a number of fish out of the area, and then as the curtain gets installed, we should hopefully have enclosed fewer fish than were there originally. It's hard to quantify whether these are successful because obviously you often don't see the movement of the fish. But in terms of Betley, we concluded that it was successful once we started doing the fish removal. So in the end, say target species was common carp. We removed less than 20 from that area. So with an estimated over 100, it's obviously a fraction remained in the enclosed area. So that was kind of, we considered that a success. The other thing that it can be used is in terms of exclosures is clever timings. And this was used not on a project that I worked on, but was used at Hobbiton Great Broad. So they used cameras. So Hobbiton Great Broad is directly connected to the River Bure, and it was known to that habitat was quite a key habitat for the common bream population. So by using cameras, they were able to kind of look at the movement both diurnal and seasonally to see, and monitor the movements in and out of the Broad by these fish. And so at a point that they were happy, they believed that there was fewer fish in there, and most of the fish were out in the River Bure itself. That is when they introduced nets, and then obviously the barrier itself. So by doing that, then there's no need to remove those fish. They're still in the system, obviously in the Bure. But in terms of fish welfare, then there's no activity been taking place. So that's a positive spin on that. Finally, something that is also available in these systems is by undertaking spawning operations. So the picture there on the left. So basically, you introduce spawning substrate into areas that are known spawning grounds. So in this case, that's at Ormesby Broad. The reed beds, there was a section of the reed bed that was predominantly common reed, but there was also reed mace in there as well. It was very popular with the bream, so we would put the introducer nets and then monitor them on pretty much a daily basis. So you go out there, and rather than spawn on the reeds, and the bream were happy to spawn on the nets, and they were happy to even though we were often there putting the nets out and around watching, they were kind of almost oblivious to our presence. So once you've known that they spawn on the nets, and you can then just simply remove the nets and dry them out on the bank. So therefore you're stopping any further recruitment of that year. Some will obviously still spawn on the reeds, but the vast majority of the eggs can be removed. Finally, there's you could stop predators. Now this is it has been done successfully in, I think it was in projects in Denmark and in the Netherlands, less so in the UK. It has been used, but predominantly after the fish removals have taken place, and you also so you're trying to shift the trying to shift the fish community back to one that is more natural with pike and perch. This has been done in the Broads. So perch was stocked in Old Fen Broad after biomanipulation. So it was a means of trying to increase that population. But it was relatively successful. So finally, it's just as a quick overview of the biomanipulation as a restoration tool. Essentially, it is an effective restoration tool. There's been several successful projects in the UK. As I say, quite a few of these have been at SSI lakes, and it has ultimately improved the conditions of the lake. So it can certainly be used as a successful process and tool. There are some well, not necessarily negatives, but you have to realise that sometimes the timescales can be. It's not always necessarily an instant fix. There can be issues, in terms of size, and also trying to get all the fish out or locate the majority of the fish. Certainly, if they're deep in margins, it means it's difficult to catch, etc. So sometimes the timescales can be difficult, and obviously with the effort that is required, there is serious cost implications. So, but also just not in times in terms of actually the barriers, whether that's those curtains or whether kind of Gabriel type barriers are built to isolate lakes. So hopefully that's been a helpful kind of whiz through the biomanipulation process. And so just to finish off, it was one of the main case studies that I was part of, and that's of Ormesby Broad over here in Norfolk. So there's a map of the Trinity Broads. in true Norfolk style, the Trinity Broad is actually made up of 5 broads rather than 3. So we have Ormesby Broad at the top, which is the most northernest one, which flows into Ormesby Broad, and then you have Lily Broad, Ormesby Little, and Filby. Filby Broad is then from there has a large drainage dike system called Muckfleet, which ultimately joins the Yare, but it's isolated from the Yare using a kind of from a sluice. Ormesby Broad is owned by Essex and Suffolk Water, who abstract from the Broad. The Broad itself is large, 55 hectares in site, and prior to the biomanipulation, it had poor water quality and a loss of submerged microphytes. So it was a good site for the biomanipulation to take place, partly because it was hopefully going to improve water quality, which would help Essex and Suffolk Water in terms of their abstraction and treatment, but also it was easily isolated from the rest of the Trinity system. So basically underneath that road bridge, there was like a 3-meter channel which separated the Broad. So a simple and easy barrier could be installed. So Ormesby Broad, the removals focused on both roach and bream, so that we had both the top down and bottom up processes in play. But in those first 3 years, approximately 9 tons of fish were removed. 79% of these in terms of number were roach, but there was also 690 adult bream that was removed from Ormesby and put into Ormesby. So again, importantly, that those fish were still available for the anglers that use the system. Following those initial 3 years of quite intensive fish removals, annual sporing exercises were undertaken with positive successes in terms of removal of eggs from the system. So how do we know that the process was successful? Well, I mean, so there was a full ecological monitoring program come on, so we could see, you can physically see the clear water, but that was obviously shown by the monitoring of chlorophyll A. So there's significant, statistical significant decrease in chlorophyll A, increases in Daphnia, and quite simply, increases in macrophyte cover and biomass. Also, in a positive way, the fish surveys, the summer fish surveys that continued, started to show that both rudd and perch were starting to recruit well. So not just kind of coming across in the first year, they were successfully overwintering. So we were getting 2 or 3 age classes in the electrophication surveys that were undertaken in the littoral margins, but also out in open water in the dense macrophytes. So yes, that was a successful project and case studies, and I realise that I have absolutely rattled through this. So I suppose that gives us more time for the inevitable questions.
Thanks very much, Mark. I think you were pretty much bang on time, give or take a minute. So although it flew quickly for you, yeah, I can show you the rest of us weren't bored by any stretch of the imagination, but you were bang on time. It wasn't rattling through at all. So. Thank you very much. Covered quite a lot of things there, and there's certainly been some interest from the crowd. So I will handpick a few questions out just to add, as I said at the beginning, if we don't manage to get through all the questions, which I think is quite likely, Mark will get a copy of all the questions at the end of this presentation, and he will try and respond to you all individually to answer your questions or take up those discussions there. Right, where to start? There are some corkers in here, Mark. I'm going to start with a fairly straightforward one. Oops, where's that gone? Just to get the ball rolling. Did you find any non-native fish species, e.g. Wells catfish? I presume this relates to your Ormesby Broad
No, we never did catch one wells in Ormesby Broad. It's not. It hasn't really. It's not an issue in the Broads per se. Although we did once find one in the Trinity Broad, the dead one in Filby Broad. There's certainly no wells in Betley at the time. Some of the ones that I haven't discussed here, there were, but that in terms of true kind of inns, wells would be the one that we've come across, but still not that often, to be honest, thankfully.
Interesting. One of the biomanipulation, it didn't end up being a biomanipulation project, but we were suggesting that as a management tool that we looked at a triple SI in the Shropshire and Staffordshire Mears area. They had wells catfish, and there was a channel that connected one of these lakes to a river that had a small grate, but the grate mesh size was sufficiently large that certainly eggs and fry of fish would be able to get through. And that had Wells catfish in it, and we found juvenile Wells catfish, and I think they were always considered relatively low risk to stock into lakes because of their inability to breed in the UK. But the fact that we found kittens, as they're known, small catfish of only sort of about 20-30 centimeters long, I think, was evidence that they can reproduce. So yeah, stocking of invasive species is definitely something that we should try and avoid. I think Geeble carp are the next big one that we're all concerned about in the UK, coming in with F1s and various other carp species. Whoops, scroll past that question that I was going to do. Probably my fault this question's posted, so I'm going to make sure it gets in there. There was a suggestion at the beginning of the talk that biomanipulation is controversial. Is there a particular aspect of the process that causes a reaction to what seems like a good response to try and counter negative human activities? I'm going to start this and then you can chip in and finish me off if you want, Mark. I'll let you off a little bit. I think whenever you're removing animals from a water body, there's always a question mark over whether it's the right or the wrong thing to do, but particularly where there's a recreational interest. A lot of people are very much focused on their own personal interest, whether that be boating, whether that be wildlife, or whether that be angling. And carp are incredibly popular fish to catch, and yet they're probably one of the first species that we would seek to remove because of the impacts they can have on aquatic environments. So there is often conflict there between anglers and people who are trying to manage freshwater systems, not necessarily for angling purposes, but more for biodiversity practices. Have you got anything to add to that, Mark?
Well, no, I think you're right. I think that's where the controversy is. It's with the angling community. But I think you can take them with you. I think that was one of the things that happened with the Ormesby Broad project. It was like, because we were telling them how we would shift away from bream, which was the angler's target species, but because one of the aims of it was to then push the fish community into things like with tench, particular, and rudd. That was like, okay, well that would be interesting because they were able to kind of still fish for bream in the wider system, but then they had something else coming through on Ormesby itself. So it can be controversial, but that's where the engagement comes basically, and that's the key, one of the key aspects of the process.
Yeah, and that's when in the few projects that I was involved with, that was probably the trickiest part of the project, was the stakeholder engagement and managing that process and managing those views and things. How are we doing? We can still got time for a few more. So let's go a BNG related one here. Obviously a hot topic in ecology at the moment. So in biodiversity net gain, habitat enhancement is a key component of delivering biodiversity uplift. So presumably this could be a key tool for delivering BNG in wetland habitats. Is it straightforward to measure the uplift?
Yeah, in a sense, yeah. I mean, in terms of kind of designated lakes stuff, then they have their targets. So there's it's simple water quality, water chemistry, but also in simple, kind of surveys of the macrophyte community. So it is relatively straightforward, not the process to get it to there, but the process of monitoring. So yeah, it's simple water quality monitoring and of the plant community will give you those answers.
Good stuff. Something for food for thought for anyone working on BNG projects. I think BNG is often very terrestrial focused, but there are huge gains to be made if we look at freshwater systems, and not just freshwater, coastal and estuarine systems as well. So, right, we'll just try and squeeze in a couple more if that's okay, Mark. Let's have a look here. So if species can't be fully removed from a system, do these lakes then need ongoing stock removal? i.e., is there a danger of roach, bream, carp, etc. becoming abundant again without further removal?
Essentially, sometimes you might need top-up removals. Sometimes that's where the sporing operations come in, because that can generally check that to stop the recruitment, and that hopefully gives a push for the other species to try and take hold. A lot of it will depend on how quickly the lake itself will react. Essentially, if you don't quickly get clear water and certainly kind of submerged macrophytes, then you may have a problem, may need more removals, because basically roach will dominate in those environments. If it's structureless, then even a small number will dominate, and they can wipe out the zooplankton. Just a kind of density of 0.2 per meter squared can sometimes decimate the zoops. So it may be necessary, but hopefully if you can get some clear water conditions and some plants back, then hopefully that push could get, that can give the push to the other fish species to try and get a foothold in there. But as with most things, it's best to monitor, so you can then get an understanding of how the fish community is responding to those initial removals.
Stuff. Right, let's see. I'll pick one more. Let's try and pick a good one. They're all quite good, actually. Let's go for this one then. Thanks, Mark. Really interesting. Accepting the challenges around agricultural runoff and treating the symptom rather than the cause, could the same or similar techniques be used to reduce eutrophication and improve water quality in a ditch network? Our ditches drain grazing marshes adjacent to the Yare. It would be impossible to completely isolate them, but we're keen to improve the water quality as best we can.
I think it would. Essentially, having got lost down many a drainage system in Norfolk, essentially they function as linear lakes because there is less flushing. So if those practices can have a knock-on effect. I mean, essentially that's what that they are there to drain those fields. So with better practices, that will often then kind of knock on into those drainage systems. So yes, there could be, and it's not as though they can't, but equally it's not as though they couldn't be isolated, because provided you use kind of permeable barriers, then that is doable as well. But yes, it should. The practices.
Yeah, I mean, that question did contain a key point there, though. So accepting the challenges around, treating the symptom rather than the cause. And I think that's always the first issue. If you've got a nutrient issue in your water body, whether that's a drainage system, a canal, a pond, or a lake, addressing those needs to be, where are those nutrients coming from? That should be the top priority, but the reality
and
is
I think in some of the instances it was, and that was the thing that what was happening was that process of eutrophication kind of did shift the fish community, and that fish community didn't shift back. It was like, okay, now we're dominant and we're in charge here now. So that was the push. Whereas because a lot of the as I was saying, and using the example of the Broads, that some of those Broads were isolated decades before biomanipulation. It was like, okay, how do we stop the eutrophication process? how do we stop them getting in? And if we isolate them and if we suction dredge, will we reduce the nutrient load into those lakes? So it's a similar process with the ditch system. Yeah.
Great stuff. Okay, we're pretty much bang on time to finish there. There are quite a few other questions in there that I've not been able to put to you, Mark. Some about monitoring, what happens to the fish, how to increase BNG, use of pike. So there's all sorts of interesting questions in there. We'll make sure those get over to you sooner rather than later, and then leave them in your capable hands to respond directly to people and hopefully strike up some interesting conversations as a result of that. But thank you very much for your presentation today, Mark. It was very interesting. By the number of questions we've got, clearly of interest to the people that have attended as well, and hopefully we'll welcome you back for another presentation in the future. Hopefully this one wasn't too traumatic.
Give me a couple of months to recover.
I think we've got the next couple lined up at least, so you're off for the next few months.
Cool, great.
Okay, thank you very much to everyone else for attending as well. As I say, the survey form will be going out to you shortly. I think it's usually within about an hour or so of this presentation finishing. We really would appreciate your feedback on both this presentation, but also the First Thursday Club series in general. If there are any particular topics that you'd like to hear, by all means, put a note in there and we'll see what we can do. We can always bring in guest speakers if we need to. And yeah, hopefully we'll look forward to welcoming you in future First Thursday Clubs. Thank you very much, everyone. Enjoy the rest of your week.
Thank you.